Hey guys, KN Rao this side. In this session, I'm going to discuss how I'm going to deal machines. Okay, definitely for sure you are going to fall in love with machines. Trust me, because I'm not going to follow any textbook. Okay? Because one thing I can tell you, if I have to follow one textbook, what does it mean? You can buy the textbook with 300 rupees or 500 rupees, or many soft copies are available. Okay, you need not pay anything. And why to pay this 27,000 rupees for plus subscription and all? Okay, that's why we are not going to follow any textbook. Everything in a practical way we are going to discuss. Everything is going to be practice only. Okay, from pragmatic approach means multiple things will be there. Kind of shaft length should be more or should be less, or area should be more or should be less. Everything, because machines means that maturity and understanding contradictions properly. Okay, so I'll tell you one small example how contradiction should be. For example, like our Indians were ruled by British, right? Now, by getting ruled by British, is it good or bad? We should be ready to say good also. We should be ready to say bad also. Okay, getting my point, right? So they have done good also. They have done bad also. Okay, so we should think depending upon the question being asked. If the question is being asked in civil service, for example, what good they have done, we should be able to answer. Okay, and what bad they have done, then also we should be able to answer. Machines means maturity, guys. Understanding contradictions means at one point we say this is right, at another point we say this is right, and in this particular process means I'm going to discuss now, you will understand at each and every step, the contradiction. For sure, you will love it. Anyway, before starting anything, I'm KN Rao, and I completed 20 years of teaching by GATE 2021 for GATE and ESC aspirants, and I'm planning to take electrical machines from tomorrow in place. Okay, and networks I started already in YouTube, and power systems I will plan and use my code KNR10 such that you will get 10% discount, and beyond that you can be guided personally by me. Okay, and then see here in Unacademy there are two kinds of platforms. Plus platform will be there, Iconic platform will be there. In Plus platform, live classes will be there, crash courses will be there, rank down batches will be there, doubt solving will be there. Okay, and beyond this, if you want some personal touch, personal guide, personal mentor, then go for Iconic subscription. In Iconic subscription, personal coach will be there who will plan your study plan. Okay, and who will give you the intricate, in-depth, critical analysis of your online test series and all, because that is very, very important. We should know our weaker areas, right? We should know our weaker areas, then only we can strengthen them. Okay, and study brochure series will be there, and study material also they are going to provide. And see here for plus for 12 months, if you use my code KNR10, it will cost you around 27,225, and easy EMI options also available. Okay, and for 18 months it is going to be 34,650, and for 24 months it is going to be 39,600. And if you plan to take subscription under Iconic subscription, it is going to, for 1 year it is going to be 40,500, and for 2 years it is going to be 54,000. Okay. Now here they thought of increasing the fee structure from July 1st onwards, but they postponed that because of huge demand from the student community not to increase. At any point of time, very soon they are going to increase. So if you want to take the subscription, take soon. And this is Spark Batch and VERVE Batch. Spark Batch is meant for GATE 2022 and VERVE Batch is meant for 2023. In this, I'm going to take electrical machines in place from tomorrow. Okay, evening 5:30 to 7:30. And Vishnu Sir, Rajyakanwal Sir. Actually, with all of them, I worked previously. They are top educators, best educators. Okay. And see here, this is for English or Hindi batches, LAKSHYA batch and AAROHAN batch. LAKSHYA batch is meant for GATE ESC 2022 and AAROHAN batch is meant for GATE ESC 2023. Obviously, faculties are top. Ankit Sir is there, Ankit Goel Sir, and Aditya Kanwal, Suresh Sir, Vishal Suresh Sir. Like, they are top. They are top. Okay. I can tell you one thing, at this point of time, you can wholeheartedly trust Unacademy. Yes. Okay. And the test series also they are providing for plus. If you take the paid subscription, you are going to get plus test series also. Now, if you want to follow me at KN Rao number 4U in Unacademy platform, such that you will get the notifications whenever I'm coming to live for special classes or plus classes or whatever it may be. Now, see here. At each and every step, okay, we understand the machine, because basically We are engineers, we are not scientists. I repeat, we are engineers, we are not scientists. Okay? Scientists will be there either at kid stage or beyond PhD stage, but we are engineers. We are economists. Always we will try to economize, or always we will try to reduce the machine cost. Price should be reduced, that's it. Because our machine is not a toy to play with. Okay? Machine is very big, right? Megawatts of power it has to handle. Always you have to keep this point in mind. Megawatts of power it is going to handle. Meaning that crores of rupees. Okay? So the moment crores of rupees, like kids play, you should not do that. Right? So always keep that point in mind. For example, measuring instruments will be there. Right? Measuring instruments, very small things. Okay? The price also can be in thousands or maximum lakhs. Okay? So the moment price is less, we can optimize them in a different way. But machines, crores of rupees. Okay? It is not supposed to be dealt in a kid's way. But anyway, in our machines, I'm going to start in this way. First, I'm starting from tomorrow, transformers. Okay? And I'll, at each and every step of present discussion, you will understand the maturity. Okay? Why I say machines means maturity. That's it. Okay? First, we are going to start with, if you think of transformers, 4 machines are there, right? So transformers will be there, and kind of synchronous machines will be there, induction machines will be there, DC machines will be there. In all the machines, operating media. Why we use magnetic field only? Why not electrical field? Okay? Of course, we know interaction of both the things should be there. Okay? But primarily, our operating medium in any electrical machine, why we are using magnetic field only? Why not electric field? This is ESC interview question. We are going to start with that. And then we are going to connect that with measuring instruments. Because in measuring instruments, we have electrostatic voltmeter. Electrostatic voltmeter operating principle or operating media is going to be electric field. Okay? Don't think that only with magnetic field only we can use. No. We can use electric field also. Again, we are not scientists. Okay? We are engineers. We are economists. Okay, that's why we are going to consider magnetic field as operating media in all the machines. So, importance of magnetic field we are going to discuss. And again, contradiction also. And because always contradiction has to be understood properly, then only we get some kind of maturity. Okay, and then contradiction is going to be electric field. We cannot say that electric field will never be used. No. In electrostatic voltmeter, we are using that electric field. But why we don't use in machines, we are going to discuss. And after that, as usual, purpose of machines, machine analysis. Okay? For example, if I have transformer, physical transformer, if I want to find efficiency, why to model like approximate equivalent circuit, exact equivalent circuit, and why to calculate efficiency from there? Directly we can take the transformer. Directly we can connect the load. We can connect 1 wattmeter here, we can connect 1 wattmeter here. And this wattmeter reading, output divided by this wattmeter reading, input is going to be efficiency, that's it. But why are we analyzing that? Okay? We are going to understand that is the purpose of machine analysis. Okay? And after that, okay, at each and every stage, I am telling you, at each and every stage, we are going to understand, we are going to feel the machine like never before, I can say. Okay? Then we are going to discuss about, okay, this is the entry point, right? Why we are entering into the subject. Then the stages of analysis. The stages of analysis are going to be 4, will be the stages of analysis. That is going to be ideal machine. In any machine, we are going to do the same. Okay? First of all, machine, we are going to consider it as ideal, and then we are going to run the show at no load and load. Okay? And then, and one more thing is, in ideal machine analysis only we are going to discuss. For example, we are having iron core, right? Iron core. And in each and every machine, because in our machine means iron only will be there in any machine. Right? Everywhere it's iron, except air gap or except copper and insulation. Okay? But the thing is, the moment you use iron in the machine, analysis will become very complex. If you don't have iron, for example, if you are not going to use iron in the machine design, then Analysis will become very simple. Complete machine analysis is going to disappear. Every machine can be analyzed with network theory. Just like with network theory, we can analyze all machines without any having complexity, without iron. But why we are forced to use iron? Why we are forced to use iron? Okay, there is no other way. It's normally I tell to my students, using iron in machines is kind of forced marriage. Okay, you cannot live, you cannot sustain. Okay, because of iron, many problems will come, non-linearity will come, understanding the machine will become very difficult, and analyzing the machine is going to be very difficult, but still, we cannot leave iron. We cannot leave iron. Okay, and anyway, why we cannot leave iron? We are going to discuss. Ideal in the sense, at no load and load we are going to discuss. This is going to be phase 1. Phase 1. But ideal machine, will you find ideal machine in practical situation? No. Okay, just entry point ideal machine we are going to discuss. And after that, next phase is going to be modeling practicalities. Okay, modeling practicalities. We are going to discuss. Okay, modeling practicalities meaning that the difference between practical machine and ideal machine. Ideal machine is already done, it is on paper. Practical machine is already existing in practice. So we are trying to bridge the gap between ideal and practical. Ideal and practical. So we will try to model practicalities. Now let us see. At each and every stage you will get the contradiction. Okay. Now in modeling practicalities, first we are going to model maybe hysteresis. And we will understand the complexity being involved in hysteresis, non-linearity. So, we will enter into non-linearity. At this stage only, we are going to enter into kind of harmonics. Though harmonics are not that much important in transform, but still we have to discuss. Okay. Then you are going to understand about harmonics a bit. Okay, introduction point. And then we are going to model eddy. Okay, and then we are going to discuss how eddy is going to be linear. Okay, why we are forced to discuss these two, hysteresis and eddy? Because we don't have any other option. Iron, that's it. Okay, only iron only has to be used in machine. There is no other way. Means before starting this, we are going to discuss about iron, and then we are going to enter into this. Okay, and then next we have to discuss no load current. Okay, modeling of no load current. No load current we are going to discuss. And about that, lots of problems we are going to do. Okay, how that flux density importance. Okay, flux density point. Normally we feel that flux density point or knee point we say, or operating point, maximum operating point. Normally we feel that it should be between linear and non-linear region. No. We are going to keep operating flux density point in non-linear region intentionally. Though we know that. For example, if I think of BH characteristic like this. Okay, maybe I can consider from here to here linear, from here to here non-linear. Our operating point will not be here, but please. No. Our operating point will be non-linear region. Okay, though we know that non-linearity will increase complexity, non-linearity will increase harmonics, but always price of the machine. Because we are not dealing with toys, we are dealing with machines. We are handling with machines. Okay, so kind of very huge. Anyway, and significance of this particular Bmax point we are going to discuss, and how it cannot be changed. Because some questions came in the old gate. Directly I say that if any flux density is being asked, obviously the same flux density point will be there, because flux density point is not a point to play with. It has to be constant at any cost, that's it. Okay, and then we are going to model leakage. Leakage, it should be more or it should be less. First of all, leakage, is it lossy or not? Many students feel that leakage is lossy. No. Leakage is lossless. It will not influence efficiency at all. But why we focus on leakage much? Getting my point, right? We focus on leakage because leakage is going to decide the terminal response characteristics of any machine. Leakage is going to, for example, voltage regulation, torque slip characteristics, or torque speed characteristics, or kind of internal, external, whatever the characteristics, okay? Voltage regulation, all characteristics except efficiency is going to be decided by leakage. We are going to discuss that. And after that, once this is over, next we will have to come to maturity. Leakage should be more or leakage should be less? It should be more also, it should be less also. In transformers, we say it should be less. But in synchronous, we say it should be more. It should be more. It should be more. Why it should be more? We are going to discuss. Okay? And after that, normal resistance we are going to discuss. Modeling of resistance, we need not bother much. And then we are going to develop equivalent circuit. We are going to develop equivalent circuit. We are going to build, after once all this is done, equivalent circuit is going to be built. Okay? Now, equivalent circuit, you got it. This is going to be phase 3. Phase 2 modeling is over. No? Now, for example, I model just resistance. Okay? Transformer, and one more thing is, you have to understand few more details. For example, if I have transformer, always we keep windings here, right? Always we keep windings here. Can't we keep windings here? Can we keep windings here and here? Yoke, we say. Can we keep, rather than keeping the windings on limbs, can I keep windings on yokes? Your sense of scientist will say that, yeah, we can keep there. But sense of engineer say that we should not at any cost, because it will increase the cost of the machine. Such things also we are going to discuss. Okay? Because practicality matters. Price tag matters. Okay. Anyway, for example, if I think of, okay, this practical transformer is there, for this resistance will be there, no, for the copper winding. Okay. Now I model that with resistance, for example. But how much is that resistance? For example, leakage I model. How much is that leakage? We have to model that, right? So, means leakage is modeled, for example, like this, inductance. Okay. Why it can be linear also we have to discuss. Okay. And it will become, leakage will become linear. Okay, and mutual will become non-linear. Anyway, we are going to discuss that also. It means once you model that with leakage with some kind of inductance, we should know how much is the value. Meaning that we are going to enter into testing. By testing the practical machine without actually loading, we are not supposed to load the machine, just under no load conditions. Actually, without loading the machine, you have to conduct tests, that is OC test and SC test. About the transformers I am handling now, because tomorrow I am starting transformers. OC and SC test we are going to conduct, and kind of polarity test we are going to conduct. Okay, Sampnas test we are going to conduct, and we are going to conduct dummy load test also. Okay, and here we are going to discuss like kind of in OC test people say LPF wattmeter. In SC test, we will say HPF. No. Again, LPF only should be used. Okay? Why? Such a kind of contradictions we have to understand. Okay? And OC test should be conducted at rated voltage and rated frequency only. No other way. Rated voltage and rated frequency only. But SC test can be conducted at any loading conditions with any frequency. You can actually SC test you can conduct at DC also, no problem. Okay? But of course, leakage finding will be difficult. That's a different story. Okay. Now, OC test, why it has to be conducted at rated voltage and rated frequency only? SC test. Okay. Such a kind of things we are going to discuss. Once testing is done, equivalent circuit, magnitudes, values of equivalent circuit we are going to find from testing. Fourth one is analysis. That is the purpose we are going to start machines, right? So, fourth one is going to be analysis. Or finding terminal response characteristics. Okay, till now we got everything. From this, equivalent circuit is built and the values of equivalent circuit is also known. What you have to do with that? You have to find voltage regulation. You have to find efficiency with indirect loading. Okay, so we are going to find voltage regulation. Again, we are going to discuss voltage regulation should be more or should be less. Both are right. Means in normal transformers, we say voltage regulation should be less. But in welding transformers, we say it should be more. It should be more. Intentionally, it should be more. Why also we are going to discuss. Okay. And efficiency, we are going to discuss. Okay. And after that, fifth one is going to be applications. Okay, so applications, we can think of auto transformer. Okay, in auto transformer, we are going to conclude almost till end of the point. We will say that auto transformer is better compared to two-winding transformer. Auto transformer is best. Auto transformer efficiency is best. Leakage is least. Voltage regulation is less. Such things we are going to discuss. At the end, one bomb will be there. Auto transformer cannot be used. Okay, so such things we are going to discuss. And after that, parallel operation. And after that, three-phase transformers. And after that, harmonics. Okay, harmonics. Actually, we are going to enter into harmonics in single-phase transformer only. We are going to start at single-phase transformer only. See here, about non-linearity, I might have written somewhere. Okay, about non-linearity. Here only we are going to give the introduction to harmonics. But at the end, you are going to get the clarity. Why we are analyzing harmonics in three-phase transformer only? Why not in single-phase transformer? Okay, and we are going to discuss kind of harmonics. Flux harmonics is better or current harmonics is better? Means we are going to conclude that let us have harmonics in current, not in flux. Not in flux. Okay, and again harmonics in flux will be there in synchronous. Okay, this is going to be the structure of transformer. After that, I'm going to start synchronous. Okay, in synchronous also, normally what people do, EMM method, ZPM method, MMF method, and all those things, they will start studying at starting. That is the problem. That is because the moment these are graphical analysis, right? MMF method is graphical analysis, ZPM method is graphical analysis. And that particular graphs cannot be given in gate. Graphs you are not supposed to draw. Okay? So in gate or SE. Okay? So that's why we are going to push those things to the end. And without having that, we are going to analyze. Then analysis will become simpler. Okay, and from transformer only we are going to build synchronous, because continuation is very much important. Means from transformer only we are going to connect to synchronous. From transformer only we are going to connect to induction, and DC is a kind of jujube for us, because no frequency, we need not analyze harmonics, no power factor, no reactive power, and in application also, where can you find DC machines? Not much. From application point of view also, it is going to be kind of, because DC machine is costlier. Okay, from starting to now I have been telling the same. We are economists in machines. We will try to reduce the cost of the machine. The moment DC machine is costlier, we are not going to use mainly. In our main power applications, we are not going to use. Okay, and again, we are going to discuss many things. Kind of synchronous motor will be there, induction motor will be there. Okay, like synchronous motor normally we don't use. Induction motor we are going to use. Why we are going to use induction motor? Because maintenance is less. But industrialists will use synchronous motor. Why? Because for them maintenance engineer will be there. Okay, for them operating cost total all over should be less. Okay, so if you think of a farmer in a field, you don't know what is meant by DC, AC and all, just he has to switch on, it has to be rotated. Okay, induction motor is going to be most rugged motor. Okay, so maintenance in rotating machines, least maintenance will be there for induction. All over the machine, least maintenance will be there for transformer. Okay, in that way, in a beautiful way, we are going to discuss with lots of problems. You need not remember many things, because once you get that maturity, in this way also you can think, in this way also you can think. Okay, in which machine this way of thinking should be analyzed, in which machine this contradiction has to be analyzed, you will come to know. Okay, meet you soon tomorrow at 5:30, the 16th, 5:30 p.m. And thank you guys. Like the session, subscribe to our channel Gate Conqueror. Okay, don't forget this. Oh, sorry, Gate Conqueror. Subscribe to here. Thank you guys. Thank you so much.